Well, hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and this week's project is going to involve motorizing my spin indexer. Let me get the camera pointed down toward the workbench a little better, and I'll show you and explain to you what we're going to do. This spin indexer is one I picked up on eBay a couple years ago. I thought a pretty good deal on it. It was missing a few items. The pin was missing. The lock here was battered up pretty bad, and the handle was missing. Like I say, it was a good deal, and everything else worked fine on it. It was not anything that I didn't think I could repair. What I want to do today is motorize this. In doing some reading on spin indexers, it seems, from what I can research and find, these were designed and originally meant to be used on surface grinders. This one holds 5 collets. Like I say, they were meant to be used on surface grinders, but people incorporated them for use on the mill. I've not had a lot of use for this since I got it. I have used it a couple times. It's great for indexing any angle from 0 to 360 or 0 to 359. But most of the indexing that I needed to do on the mill involved a hex or square, and I was able to do that with collet blocks that I'm sure most of you are familiar with. But I thought it would be a good implement to use over on the surface grinder if I could get a steady rotation. And to do that, motorizing it, I believe, will be the best thing to do. I've seen a couple of examples where these have been motorized, and every one of them is a little bit different. This one actually had a badge at one time that's gone. It has a part number on it, D1-100. Hadn't had a whole lot of luck researching that. But what we're going to do is from the back side here. Oh, and one other thing I want to mention about this one, since I've gotten it. Most all spin indexers have the front face of it. All this surface is machined. I have taken this one apart and also machined and surface ground both sides, front and back, or left and right, to be perpendicular to the face edge, and also surface ground the back to be parallel with the face, or to the front, so it's perfectly square, and all four sides are machined. I've gone ahead and cut a little bracket, but what we're going to do in this video is mount this bracket on there. I'm using aluminum for this. This is a piece of 1/2 inch by 3 inch. I'm using it because that's what I've got. A piece of 1/4 inch steel plate would have worked fine there. Probably 3/16 would have worked fine. But this is what I've got. So what we're going to do in this video is mount this to the base of the spin indexer. We're going to drill over here and mount a motor. The motor I'm going to use is one I've got here in the barn. This is a gear motor. It's not necessary to use a gear motor. If you see any of these motorized, you'll see a little motor mounted over here with a very small pulley on it, and then a large pulley over here to get speed reduction. This is a gear motor that I already had. It was originally used on my Precision Matthews 727 mill as a power feed for the X-axis on the table. I used one of these on my X2 mini mill. Works fine, worked great for it. It's 180 RPM, and that turned out to be a little bit slow for my larger mill, the 727. So I put a different motor in that and still had this one. The shaft I have squared off somewhat from what it was, but it's still got enough of the rounds left here that I think I'll be able to put a pulley with a round hole in it, 12 millimeter, to fit that. But this is going to be mounted over here. Be mounted through there. So we'll have to mount this. We'll have to come up with our hole pattern for mounting the motor. We'll need to make a pulley for the motor. The belt that I've got says turn radius on it. It's a belt that you actually put together from McMasterCarr. I bought 10 feet of it simply because the connectors come in packs of 25, and I figured, you know, it may come in a good later. But this says this is 3/16 diameter, and the smallest pulley it should be used on is 1.5 inches. Probably going to go 1 3/4, probably even between 1 3/4 and 2 inches for this pulley. And this one over here will be 3 inch. I don't need much more speed reduction. And I know these motors have got plenty of torque and plenty of amperage to them. So I'm not concerned about it not having enough power to pull this. These are available on eBay. These are 12 volt DC, and I do have several 12 volt power supplies here in the tin barn, so that's what I'll be using on it. These are available on eBay. I'll try to remember to put a link in the description if anyone is interested in these gear motors. So the first thing we're going to do is turn over to the mill and drill the mounting holes in this, in the bracket itself. Then I'll disassemble this, and we'll drill and tap the matching holes over here in the base. To mount the motor plate to the Spindexer housing, I'm going to be using 1024 socket head cap screws. Now I've got the first hole laid out right here. The clearance hole for number 10 is a 3/16 bit that we'll be using. We're going to go 1 1/4 inches on each side to for our, be 3 holes across the bottom here, and then there'll be 1 hole up here, and that'll be, I didn't write that down, but that'll be 3/4 inch from from the 0 we have set now. So now I'll go 1 1/4 inches on the X. Now 1 1/4 inches on the other side. Now we'll come back to 0 and go 3/4 inch on the Y-axis. Alright, I was seeing a little deflection there with this hung out here. I hung this off to the side because I didn't want to hit my parallels. I'm going to get a jack and put it under here and be right back. I've got one of my jacks under here now. If you've not seen the video where I made these jacks, I'll try to put a card to it up in the corner up here that you can check that video out as well. Again, the clearance hole is going to be a 3/16. Now we're going to counterbore for the socket head cap screws. Zero out my Z-axis. Come down 188 thousandths. Okay, I'm going to get these holes transferred over to the base or the housing of the Spindexer, and we'll drill and tap them. One more item I needed to do to the plate before I take it out was to drill this clearance hole for the motor. Now we'll have to come back and clear or drill the other 4 mounting holes, but for the shaft on the motor, I want to be able to line it up with a template that I've made. So I'm going to drill a 1/2 inch hole I'm actually going to drill this 31/64 and then ream it out to a 1/2 inch. It doesn't necessarily have to be a reamed hole at all, but that'll just make it a little cleaner. Alright, now I think we're ready to remove the workpiece and start working on the... I think what I'll do is go ahead and lay out for the motor and drill and tap or drill those mounting holes. Alright, now we're ready to lay out this for the mounting holes, and then we'll move on to the base or the housing of the Spindexer. As I said earlier, the motor I'm going to use on this is one that I had used before for the power feed on this actual mill right here. Got to looking, and I found the mounting plate that I was using on this mill when I had that motor on there. So I'm going to use it to lay out the holes. I'm just going to use this 1/2 inch dowel here. And let me double check. The narrow hole pattern will definitely need to be at the top. I'm going to go ahead and lay out all 4 of them at one time. Want to be sure it kind of stays in place. Now I can just use a transfer punch. Yeah, I got good marks on that. So I'm going to check. I believe this is a 6mm, but I'm going to get the necessary drill bit, get it in the chuck, and get set up to drill these holes. Okay, it turned out this is actually a 5mm. So I'm going to drill these 4 mounting holes. Okay, so I think we are finally ready now to carry this piece back to the workbench and lay out the housing for the Spindexer. All I'm going to do is lay out this one hole right here. I've got the dimensions to these 2 and to that third one up there. So I'm going to lay that out and I'll bring you right back. Alright, I've got the main housing for the Spindexer mounted in the vise now. As I said in the introduction, this face is machined all the way across. It is a machined surface. So I've got it flat down in the vise now. My vise won't open up quite enough to get these shoulders, but it's held in there good and tight. I've located this starting hole, and I raise that up just a little bit so that when the housing sets on here, I didn't try to make it flush with the bottom. I do not want it to interfere at all with that, so I raise it up probably about, I don't know, 20, 30 thousandths, something like that. So let's lay out these 4 holes. Now they were 1 1/4 inches apart. While we're right here, we can go ahead and get this one at 750 thousandths. Make a 0 on the Y, on the X. 1 1/4 inches. This is the tap drill for the 1024. Okay, let's get set up with a 1024 tap guide and wrench and so forth. Okay, I've got the tap guide up here in the chuck, tap handle on, 1024 tap, and don't usually use any kind of lube on cast iron since it's got enough carbon in it to be its own lube. But I'm going to put just a little bit on there on the tap itself just to hopefully help those chips to to go away. Alright, now I got it started. Beginning to wonder if I'd used too big of a tap drill. Using a two-fluted spiral tap here, that's why I'm not having to, that and the fact this is cast iron, that's why I'm not having to break the chip by reversing. I am when I get down close to the bottom, just to be sure I am bottoming out the tap. Alright, I'm going to check this out on the workbench, be sure everything lines up like I expected it to, and then we'll start turning some pulleys. Okay, let's see if our holes lined up. Alright, that part's good. Now we'll check our motor mount. Now this housing is obviously set back from the motor itself housing, the gearbox housing set back from the motor housing. So what I have, and again this is from the previous, I have some bushings already made. This is all from the previous mount and some longer screws. So I'll use those to put all this back on this mount. And again, the 4 spacer bushings. Alright, that looks like it's going to line up. Alright, that is a little lower right there. If I had noticed that, I would have brought that up a little bit higher. But this is going to be setting on a platform anyhow, such as the sign plate or the extension plate, so that it hangs off the side of the mag chuck. So that's going to be fine there. I think it's time now we start working on pulley for the motor, and then a pulley for the spindle. I'm going to make the pulley for the motor shaft first. I got a piece of 2-inch stock material in here, just a piece I had over there in my bin. This is about 0.8 inches long. I'm going to face off, I've already faced off the other side and got it turned around. Of course, again, I've got my spider plate in the chuck to kind of hold it off from the body a little bit. Alright, now we're going to drill that out to match the motor shaft. And the specs on that said that the shaft was 12 millimeter, or that's what the description on eBay said. But I've measured it. 12 millimeters is about 4.72, and it measures out to 0.461. So I don't have a 12 millimeter bit anyhow. So I'm going to drill this and then start with a 3/8 inch boring bar and bore until we have a match to the motor shaft. The camera arm is right where I've bumped it twice in this, so I'll try to be a little careful as I'm drilling. Alright, I've got the camera in hopefully a little better position now so I don't keep bumping it. Double check one more time that this drill bit I'm starting with, yeah, that's about 430 thousandths. Alright, let's see if the 3/8 boring bar will go in there now. It should. just barely. So I'm gonna make just a couple passes to clean it up, and then we'll get a measurement. All right, let's see where we are. It's 457. So we need, wow, we don't need about 4 more thousandths. Might be just a little bit slack, but I think some of that again is where I squared off this shaft. So what I may very well do when I put the shoulder on here to put the set screws, I may go ahead and put 4 set screws around there and treat this just like a 4-jaw chuck, tightening on the 4 sides. Because as I look down here closer to the end, I definitely did get on that round some when I was squaring this shaft up. But I've got this motor and I want to use it, so we'll make it work. Just make a spring pass though. Now we're going to get set up to turn the outside diameter of this, so I'll be right back. The hole we bored in here, 461, actually come out about 462. But the smallest expanding mandrel I've got is a 1/2 inch, a number 1, which is a 1/2 inch. But I was able to squeeze that together enough to get it on there, so we can turn this between center. Now this is 2 inches. I want to bring that down to 1.6 inches. The belting material that I got, the connectors for it said the smallest diameter pulley would be 1.5. So I'm going to make this just a little over 1.6. Let's see where we are now. We're at 1.975. So we need about 375 thousandths to go. We'll take a few cuts and then come back and measure again. All right, let's check that again. Again, we're looking for 1.6. It's 1.675. All right, now I'm going to use a forming tool, just something ground up. I believe this is the right one. Nope. This is the right one. Just one I ground up to pretty much match the diameter of the belt material. All right, let's slow her down just a little bit. All right, I think I need to tighten it up on the shaft, or on the expanding arbor a little bit. I'll do that and come right back. All right, let's try that again. Still getting a lot of chatter. All right, I want this belt to be able to set down in there. I believe I need to widen it up just a little bit. Again, I believe it needs to widen just a little more. I did not have the belt material when I ground this form tool. That looks good now. I believe this might be just a little more than 3/16. But that looks good. Now what I'm going to do, I'm going to put a step on this so that we've got something to put the set screw in. And I'm just going to eyeball the thickness of that, the shoulder I've got over here. I'll set my X to 0. looks like about 133 thousandths. So I'll come to this side, set 0, come in 133, and set my carriage stop. So what we're going to do is get a little witness line there so you can see where I'm at. Alright, so from this edge to that witness line, we're going to take it down to where maybe got a 1/4, 3/16 left for the set screw to set in. And I'm going to go ahead and put a new insert tip out front. This doesn't have to be any particular size. I just want to be sure that's small enough to rotate within the bolt heads where it's mounted. That way I can get it up. Alright, I think we're ready to go over to the mill now and drill for our set screws. Alright, our motor shaft pulley I think is machined now. This is the groove for the belt, of course. Now what we need to do is drill and tap for some set screws. And as I said over there on the lathe, I'm going to go ahead and put 4 in there so you can work on those square shoulders just like would a 4-jaw chuck to line this up with the motor shaft. So let's find the center on the x-axis. Now I want to find this front edge right here. Alright, now we want to come over half the width of the probe, which is 100 thousandths. I'll re-zero. Then we're going to go half this distance of this step we put on here is 160 thousandths. I've got some 1032 by 1/2 inch long set screws that I'm going to use. I had rather have used number 8, something a little smaller, but just don't have a selection of them left. Let's see, we probably better that round surface. Probably need to use a starter drill. And I'm going to drill this through this top and the bottom. Now this is a 2-fluted spiral tap here, and I believe in this aluminum we'll be able to get away with power tapping it. Put it in a low range, low gear. Now I want, as best I can, turn this 90 degrees. I've got the table locked and got a work stop over here. So I'm going to thread that tap back in there just enough to help me sight this against the vice jaw. Alright, I think we're ready to move on to the spindle pulley now. Start on that. I'll deburr this. Be sure the threads went all the way through the opposing sides. And then, like I say, we'll get started on the pulley for the spindle of the Spindexer. there's still not much video footage to including this video, so I think this is a good place to wind up the first part. While you're waiting for the second part, check out my buddy Harold Waters over at Amateur Redneck Workshop. Harold has a lot of good projects going all the time, and sometimes he even has a funny joke. So stay tuned to this channel for part 2, which will be coming out in just a couple of days.